Sinem.
And my name is Alexander Rush.
We are students at University of Houston Downtown, and today we will be explaining about our pandemic issues, epidemic issues that we want to show to the kids. So, go ahead. Elementary school. And here we have our issue. First of all, the epidemic. What is an epidemic? Epidemic is a widely spreading bacterial infection. Usually, recently that we have seen is the influenza H1N1 that was affecting the public city and metropolitan cities because people using the formats, through formats, using public transportation and all these public places used to carry a lot of diseases to their homes, and it could not be stopped very fast. And when it spreads to a large population, it's called epidemic. And we want to explain this situation and protect our kids from future epidemics and make them ready to clean their hands and make sure that they don't get infected through fomites, which are objects that can carry some kind of infection. And our hypothesis in this experiment is that if we have yeast exposed on a coin, 25 cents, and it is passed among the individuals, those individuals will be exposed to yeast.
And an epidemic can be caused by anything, like he said, bacterial or viral or a fungal infection. What we have here is our experiment. I'm going to come here, Enos, if you want to just hold on to these for me. These are our hydrogen peroxide tubes that we will be using. The first step that we did in the experiment with the children was go and make up a yeast solution, which is regular water and active dry yeast. These are microbes, like he was saying, that will be used to go and track on that coin. So what we do is just stir those up. And then what we do is we had a coin that we go and we actually had 2 coins because we did this experiment since we had such a large group of children. We had 6 children. We went and used 2 groups of 3 to go and pass around these coins. And what we did was we just took the coins and dunked those in there and then shook off all the excess moisture and any other particulates that we had on, and then we just kind of let those dry out for just a little bit. And then what we would do is we actually pass these around, and if you want to put those in one hand, what we did is we passed these around so the children would grab them with just their pointer and their thumb finger. So you can just grab it with just your fingers actually. And just with those, and then we had them just rub their fingers along, and then they would pass it to the next student, and the next student would grab it in the exact same manner with just these 2 fingers and touch that. And then what we did was we wanted to go and check for any microbial growth or microbial foreign bodies that were on the hands. The way we did this was by going and swabbing with sterile water just lightly on the infected area. Right now we're using gloves, but with the children we actually used their regular fingers after they went and washed their hands. And then what we do is go and note the bubbles. Whenever we put the cotton swab that should have microbial particles on it into the hydrogen peroxide, we should see some little bubble formation through here if we went and had any. And you can notice a little bit of bubbles coming up through there. It might be a little bit hard to see on the body, but that would be noted as a 1+ reaction. The more bubbles that we do have, we go and mark those as well, and you can see a lot of the bubbles going and forming through there. And what we did was we did that for each child as they went and passed it through there, and we also went and showed the children just what a positive control would look like. So we went and dipped in just the cotton swab in the yeast suspension. Then we went and put that in the hydrogen peroxide to show them a positive control. And there you can definitely see a lot of bubbles. That would be what we would call a plus as far as the results go, with a lot of bubble formation. And then we did one more test where we went and dipped it in just sterile water, which is what I have right here. This has been autoclaved in a gas autoclave. And we put that in just 1 hydrogen peroxide tube just to show the children that there was no bubble formation whatsoever on here, unlike the 1 bubble formation and the one where we went and had when we swabbed Enos's fingers after we went and touched that. And so we have the results that we went over with the kids. Now our partner Perla is going to go and come and step in here. Come over here for And this right here is our BED partner. Go on and introduce yourself.
Hi, my name is Perla Cordova, and I am their BED partner. and our class is a group of 6 students, and they're 4th graders.
All right. So whenever we went and did those, again, we had split the group up into 3 different ones so we could repeat the experiment twice. And so we had 3 children going and passing the coin, and then each time we went and swabbed their fingers to go and check for bubbles. And what we noted was, on the first one, whenever we did this one here, we had a good positive result whenever we swabbed the first student, who was the first one to touch the coin and rub his fingers on the coin. We had not the same amount that we did on our control, but we did have very good bubble formation on there, so we denoted that with a plus plus. And then whenever they passed that to the second one, again, grabbing that with their pointer finger and thumb, we had a 1+ denotion, and then again on the third. So we had 3 positives. Our second experiment that we went and had, we went and did this one, and we actually had 2 pluses with the first initial student that went and had that, where they went and rubbed their fingers really well. And then on the second one, we just had 1+ with just a little bit of bubble formation with this, on the second kid in the second group. And then the third student actually didn't have any bubble formation whenever their fingers were swabbed. This is more than likely due just to the vigorousness that the students have went and rubbed their fingers with. And this is also another good example to show just how far and where epidemics can stop, and why some people are affected and some people are not affected by certain microbes or infectious bodies. So this was a very good experiment to go and show the students and teach the students about epidemics and how they're spread, and again, the importance of hand washing, covering their mouths whenever they go and sneeze or cough or anything like that. And we'd like to go and thank Crockett Elementary School for having Enos and I out here, as well as getting to work with Perla. It was a very fun experience going out and doing the service learning. We look very forward to going and doing our presentation and presenting at the SRC.
For the rest of the experiment, we wanted to show the kids that what kind of microbes can grow in what kind of objects, and we wanted to really expose the kids and show them how many bacterial colonies, indicating how many different bacteria can be in every individual object around them. They can use the doorknobs, they can use the telephone, they can use their phones, and even on their hands, maybe after coming from the restrooms, and see what kind of bacterial state on their body. And in order to show this, we wanted to obtain 6 agar plates and 6 sterile loops, disposable, so kids do not have to get engaged with firing and sterilizing them. And incubation, at least in room temperature, just 25 degrees Celsius, but it will be better if we keep it at 7 degrees Celsius so that they grow faster, since it will be right next day in 24 hours. So we want to show the kids how they can see, the results will be like, there might be some colonies, hopefully we don't see a lot, and we will show them that this is what you expect, and the results are open to their eyes. Hopefully it helps better.
My name is Perla Cordova. I am a PD2 student from Dr. Bhattacharjy's class. I was paired up with the microbiology students that were conducting the epidemic simulation experiment. What I learned in the process of getting the 4th grade students ready for the experiment was that they enjoyed information presented in the form of animated videos, hands-on activities, and acting it out. Like most students, if they were seated for too long, they tended to get bored. Therefore, I tried to incorporate activities that got them moving. Being that they needed to learn the scientific method, we conducted an experiment in which we used baby powder to simulate a cough when someone doesn't cover their mouth. The students had to use the steps of the scientific method to complete the experiment. I also feel that this experience has allowed me to establish an open form of communication between myself and the students' parents. I was sending weekly updates of the topics and activities the students will be covering throughout the week. Some of the parents were sending questions regarding where they could find additional material to have at home to provide their students, which I referred them to the public library, several YouTube videos detailing the scientific method, some educational websites that provided quizzes pertaining to the vocabulary the students were learning at school, and government websites that had information about epidemics and how government agencies have tried to stop epidemic outbreaks in the past. I feel that this experience wouldn't have been made possible if it wasn't for my microbiology partners, Alexander and Inez. They were the ones who provided me with the initial vocabulary list that they felt the student needed to learn in order to be prepared for the epidemic experiment. They also provided me with an outline of the experiment, which allowed me to prepare myself and the mini lessons I was presenting to the students. Thanks to this experience, I would like to thank Dr. Bhattacharjee, Dr. Gulati, my microbiology partners, Alexander and Inez, for providing us with information, with this activity that was informative, fun, and according to my students, life-changing. Thank you.